So for this example, the vertices of a parallelogram ABCD are these points. If ABCD is reflected over the x-axis, how many points remain invariant? So what that means is how many points remain the same. So remain the same. Invariant means like not varying. So remains the same. So the best way to do this is actually just to kind of sketch it. So if you look, we have 2, 0 is A. We have 0, -3 is B. The picture doesn't have to be perfect, but you at least want to have a rough idea. C, we have 3, -3. And D, we have 1, 2, 3, 4, 5, 0. So we have this. So now if I imagine reflecting this over the x-axis, B is going to come up here, and C will come up 1, 2, 3. So 1, 2, 3, it'll be up here. And A and D, though, are going to stay basically on the line because they don't have to travel anywhere. So here would be your new parallelogram. So basically, how many points remain invariant? Well, how many points stayed the same? There are 2. There's a point here and there's a point here. This next example, which expression best describes the transformation shown in the diagram below? Well, let's look. This is talking about orientation. So that means where you draw on the arrows and you decide, did they stay the same or did they change? So I always just go in alphabetical order. Make sure you stay in the same order. So if you look, these arrows are going to the right, where these arrows are going to the left. So the orientation changed. So it can't be choice 1 or choice 3. So it's got to be an opposite orientation. And if you look, basically to go from triangle ABC to the prime triangle, I had to flip it. So this was a reflection. I know that translations can never be opposite isometry or opposite orientation. So right away, I looked at number 4 and knew that wouldn't work either. So one more example here. If I have this rectangle and I reflect it across the x-axis. So let's go ahead and actually do that because it'll be a lot easier to answer the questions if you actually are looking at the new picture. So reflecting across the x-axis, so count 1, 2, 3, go 1, 2, 3. That'll get you A prime. Then from B, this was 8 units down, so I have to go 8 more units. C is up here at 10, so I just go 10 units down. And D is at 5 units to get to the x-axis, so travel 5 more units. So here's your new rectangle. So now we can go through and answer these questions. So it's asking you which will not be preserved. So if you look, the slope of AB is some kind of positive number, where once I reflected it, now it's a slope going downhill. So I went from a positive slope to a negative slope. So right away, that has to be the answer. The slope changed. Where parallelism just means, if you look, AB and CD, those are parallel right now because they're opposite sides in a rectangle. If you look at the new one, they still stayed parallel. Even though they were both negative slopes, they're going to be the same slope. The length of AB. Remember that reflections preserve length. So the length is going to be the same. So that didn't change. And then the measure, reflections also preserve angle measures. So these angles would have to stay the same. So that's the only thing that's going to change is the slope because of the orientation changing.